3.1 Functions. A function consists of a set of inputs that's called a domain. Additionally, a function is a rule by which each input determines one and only one output. In other words, I can't have more than one output. If I do, it wouldn't be a function. And it also consists of a set of outputs that's called the range. All right, example one, determining inputs and outputs of functions. So draw this little chart I have here. Well, it's not a chart, it's a graph, but draw the graph. And so here we have temperatures going up the left side, and across the right side we have a 24-hour period from 0 to 24, which is a whole day, for those of you who didn't know. 24 hours makes up an entire day. First, we're going to describe the set of inputs, the set of outputs, and the rule for the following functions. That's not part of the first question. I apologize. All right. For this one, what would be our inputs for this? So if we want to describe the input here, which is the domain, that is the hours. So our input is the hours of the day or the time of the day. Our output is the temperature. So if we start in the morning, as time goes on, starts at 0, and our temperature increases and then decreases into the evening. And by midnight, it's pretty chilly outside again. All right? That's kind of the way the world works. If I was looking for my actual domain, it would be from 0 to 24, inclusive. And if I was looking for my range, well, here I got to kind of estimate. This would be about 35, and it goes below that, so say about 33, and then up to about 64. So my range would be from 33 to 64. And it's just a little bit of an estimation or a guess. Pretty easy, right? Now we're going to have some additional functions here, and I want you to describe the set of inputs, the set of outputs, and the rule for the function. So the first one is the amount of income tax you pay depends on your income. What would be our input? our input for this function, so the amount of income tax that we pay depends on the income. So how much our input determines our output, which is how much we would pay. So our input is our income. Our output is our tax. I don't know why I wrote tan. The word is tax. And it says in the rule for the following functions, the more you make, the more they take. That's our rule. The more income we bring in, the more that they take away from us. Your tax rates actually increase as your income increases. So if I make about $50,000 a year, I'm currently paying about 33% of that money goes to taxes throughout the year. Not just income tax, but the Social Security tax, state taxes, everything on top of that. Local taxes, that's about 33% of the money I make. So for every $3 I make, they take approximately one of those dollars. The government for taxes. Under our current plan that's in place, people who make over $300,000 in New York City, for instance, they're making $300,000. Their income is $300,000. However, their out or what they're going to pay out in taxes is approaching 56%, I believe. So for every dollar they make over $300,000, they're going to be giving 50 cents of that dollar away or 56 cents away in taxes. So they'll be taking home less than half of what they make. So the more that you make, the more your tax percentage increases. So the more you make, the more they take. All right, suppose a rock is dropped straight down from a high place. Physics tells us that the distance traveled by the rock in t seconds is blank feet. I believe that's supposed to be 9.6. When we look at this, we're looking at the distance that gets traveled, right? And what does that depend on, that distance that's being traveled? It depends on how long it has been falling. So our input would be t, or the time. And it's time in seconds, right? Then our output would be how far it fell. Or the distance. Also, this is not 9.6. Our functional rule is 16t squared. So we can calculate our distance based off of this formula. I was thinking there's a formula from physics that's like 16t squared, I think minus 9.8t plus, and that's like where your height comes in or something. I don't remember. But that's our functional rule. It's just 16t squared for how long or what distance is traveled per second. All right, part C. The Weather Bureau records the temperature over a 24-hour period in the form of a graph. The graph shows the temperature that corresponds to each given time. We actually already did this one. This one was the graph that came from the top. So this graph goes with that question. I don't know why I put it up there, but I did. So our input is the hours or the time. Our output is the temperature. And our functional role is just whatever the graph is. That takes us to example 2, which is determining whether a relation is a function. So we've done this before. This was in Algebra 1, Algebra 2. We're just kind of rehashing this. Determining whether a relation is a function. The table lists the inputs and outputs for two relations. Determine whether each relation is a function. So now I want you to think back to those days and see if you can remember how you determine whether something is a function. There's a couple ways. One is to graph it, and there's a certain test that you do. The other one is by looking at this table, and you can tell if something happens. Yeah, exactly. If our top ones do repeat, it is not a function. So we have 1 and 1, so it's automatically not a function as long as these numbers are different. The 3s would also mess that up. So this one would be not a function. What about the next one? Is it a function? Yes, the second one is a function simply because the top numbers don't repeat. The bottom numbers are allowed to repeat, and it would not create a relationship that is not a function. Another way to think about this is if we were to graph it. If I graphed this top one, let's just say I go over to 1, and then I have to go up 5. I have a dot here and a dot here. So that would fail the vertical line test. If a vertical line goes through the function more than once, or through the relationship more than once, it is not a function. So this would fail the vertical line test. That makes it not a function. All right, example 3. The value of a function f that corresponds to a specific input value a is found by substituting a into the function rule and simplifying the resulting expression. So here it says find the indicated values of f of x equals the square root of x squared plus 1. And then it gives us f of 3, f of negative 5, and f of 0. So whenever we look at this, in order to figure out what we do, this is our input value. So that's all f of 3 means. A lot of people will do 3 times f. That's not what it's asking you to do. It's asking you to put this into the equation everywhere you see an x. So this is now f of x is f of 3, which means we put an 3 in for the x over here. Square root of 3 squared plus 1. 3 squared is 9, plus 1 is 10. So it's the square root of 10. And that's your final answer. Part B, you just put a negative 5 in everywhere you see an x. Square root of negative 5 squared plus 1. Negative 5 squared is 25, plus 1 is 26. This is the square root of 26. Part C, put a 0 in. Square root of 0 plus 1 is 1. Square root of 1 It's just one. And that's it for the day.